Hi everybody and welcome back to Mr. Gard's maths class. Today we're going to be looking at index laws again, but this time at a different index law, raising powers. So this time we're going to have to remember that pronumerals are letters that represent an unknown number. Now in this case, if you look at the screen, the first one is x to the power of 4 in brackets. All of that has been cubed, so raised again to the power of 3. That's why we're calling this raising powers. So a number that is already to the power of something is raised again. So if we're really thinking about what this means, we have x to the power of 4 to the power of 3, which means, as moving to the right, we have x to the power of 4 multiplied by x to the power of 4 multiplied by x to the power of 4. Remember, that little 3 up here tells you how many times it's multiplied by itself. If we were to expand each one of those brackets, each set of brackets there is x to the x multiplied by x multiplied by x multiplied by x, which is what x to the power of 4 means. That's happening 3 times over, so that's how we get to the second line. Because everything's multiplied, we technically don't need the brackets in there. Now that I've removed the brackets, the number is no different. The difference now is that we actually have 12 of those x's multiplied by one another. So if I'm going to just change the pen back to this color, what we actually have is x to the power of 12. It doesn't matter which way around we multiply those x's. It's x times x times x times x and so on until I've done that 12 times. Now, just as in the last lesson, you might see a bit of a pattern with those two numbers and the 12 being formed. You're right, they have been multiplied together because we have 3 lots of the x to the power of 4, which multiplied together gives you 12. We'll run through a quick example here. Here the number is 2 to the power of 3 to the power of 5. So if we think about that, that means 2 cubed multiplied by 2 cubed multiplied by 2 cubed by 2 cubed. Remember, we're doing this 5 times over. Now, I could expand them again to be 2 times 2 times 2. That's that one, times 2 times 2 times 2, which is that one, and so on. Ultimately, I'm going to end up with 2 to the power of 15. Now that's going to be a really large number because 2 times 2 is 4, times 2 again is 8. 16, 32, and until we get 32,768. 32,768. That is what this number equates to. But notice again that this 15 came from 3 multiplied by 5. So now we can fill in our first golden rule. A to the power of m to the power, all of that to the power of n is a to the power of m multiplied by n. One more example down below is a slightly trickier one. According to our rule, u squared to the power of 4 means we have u to the power of 8. because it's u squared times u squared times u squared times u squared. Multiplied by, and this is where it gets a little trickier, everything inside this set of brackets has a power to it. Even that number 7 is to the power of 1. I'll let that sink in for a second. That is 7 to the power of 1. Now what we're saying here is we have 7 to the power of 1 times u cubed multiplied by 7 to the power of 1 u cubed. So let's keep going. U to the power of 8. Now 7 to the power of 1 times 7 to the power of 1 is 49, or 7 squared. Notice that that comes from 2 times 1 is 7 to the power of 2. U cubed times u cubed is u to the power of 6, or u 3 times 2, like so. Now, let's put the number out in front, so 7 squared, we can now call that 49. And u to the power of 8 times u to the power of 6, according to our index law from the previous lesson, remember where we add those two powers together when the bases are the same, we get u to the power of 14. U to the power of 14. And we rewrite that 49 u to the power of 14. And one final rule that I'm not going to go into today in great depth is x to the power of 0, up the top in green. Anything that is to the power of 0 is equal to 1. It's as simple as that. A million to the power of 0 is always 1. Hopefully that is of some assistance for today's lesson in raising powers, and I wish you luck for your questions.